Hello and welcome back to Neural Networks from Scratch in C++. In this video, we are going to be coding the matrix multiplication plus bias that we discussed in the last video. So remember that in the last video, we were talking about why we were separating the bias in the first place, and we ended up, motivating this new broadcast addition operation that we're going to be doing. So the motivation was that essentially, we didn't want to have a matrix that has a bunch of duplicates, because remember that what we're going to be doing is that once we do a particular dot product, what we're going to do is, like, for this entire column, we want to add this bias term, so this b0. So instead of duplicating and having b0 plus this, and then having another b0, and then plus this value over here, we essentially just keep a row vector and we do this broadcast addition. So what we're going to be doing is we're going to be adding this b0 to the entire first column, b1 to the entire second column, and then bn to the entire nth column. So what we want to do is we want to make a new type that's not a matrix, because we want to have a type that doesn't have any concept of rows, because it's just a one-dimensional thing, right? It's just, you can think of it as a list of numbers, kind of like a row vector. So I'm going to make this new type. And the reason I'm not just using an array is to be consistent with the fact that we have this matrix, and I don't want to just add an array to a matrix. I want to be consistent with the way that we put our shapes first and then the types after. So we're going to put array of t and c. And now I'm going to pretty much copy this matmul stub, and I'm going to make a new function called matmul plus bias. And the entire template is exactly the same as the matmul one. We just need to make a new argument to this function. And this is going to be called, it's a bias with nc entries, so the number of columns, also of type t, and we're going to just call this b. And now I'm going to copy this and implement it in my TPP file. So the matrix multiplication plus bias is almost identical to a normal matrix multiplication. The only difference is now I have to add the bias. So remember that in a matrix multiplication, the way that we were doing it in the optimized case was so let's say that this is our first matrix and this is our second. Mathematically, we were iterating over the columns of the second, and we were keeping the rows fixed until we iterated over all the columns. So we start with this column, we do the dot product, and we store the output over here. So we store the output, then move to the next column and store the output. And then finally, when we get to the last one, we store the last output. Then we move back to the first column, and then we move to the next row. So essentially, after every single iteration through all the columns, we've created a row in the output. So what we could do is that once we've created this row, we can now just add the bias to every single entry in this row. So we would just iterate over this bias vector. So there's b0, b1, all the way to bn, and then just add term by term. So add this, and then add this and this, etc., until you get to here. And then when you've filled a new row after doing the exact same thing that we discussed before, then you just do the same thing again. You add this and this. So it's actually very simple. Let's go back to the code now. So after we've filled an entire row, which is described by this, we can now iterate over all of our columns. And we already have the row over here, our result row, and all we have to do is add our bias at C. And that's it. This is the only change that we have to do to incorporate the bias. So now what we're going to do is this comment now, this goes above here, and we already timed these. We don't need to run this again. So let's actually do a little test to see that this works correctly. So what we're going to do is let's make a new function that creates an A range just like we did for the matrix. So we have a matrix, create matrix with an A range. We're going to do the same thing for the bias. So I'm going to copy this entire function, and I'm just going to replace, instead of matrix, I'm going to put in bias. And biases don't have rows, it's just a one-dimensional thing of size NC. And I'm going to replace matrix with bias over here. And I'm going to copy this into the TPP file, and I'm going to put it right underneath the create matrix. And I'm going to copy the entire body of create matrix, and I'm just going to replace what I need. So matrix now becomes bias. This comment is not relevant anymore. And then we just remove the outer R loop because we were just iterating over C. And instead of mat, we're going to call this B. And we remove the index at R and return B. And that's all we need to create a bias. Okay, so now let's go back to our main function. And what we're going to do is we're just going to print a normal matrix multiplication, and then we're going to do it plus bias, and we're going to see that this computed the right result. So what we're going to do is let's make a matrix. So create matrix 2 by 2, integer type starting from 0, and the same thing for B. And we are going to just print our matrix of mapmul AB. And remember, we are not just doing a mapmul of AB, we actually need to pre-transpose B because of the fact that we want the columns to be contiguous in memory. So let's transpose. Let's compile. And let's run. So this is what you should expect. If you don't believe me, I mean, we've done this a bunch of times, but 0 times 0 plus 2, then 0, 0 plus, so this would be 0 times 2 plus 3 times 2, so that would be 6. Then this would be 3, then 2 plus 9, 11. So 2, 3, 6, 11, which is exactly what you see over here. Okay. So now, if we were to add a bias and an A range bias, so the A range bias would look like this, 0, 1. And now I'm not going to put the equality now because this is like a separate thing. So here's our matrix, and we are now doing a broadcast addition with this 0, 1. So you would expect this 0 gets added to the first column, so 2 and 6 are added to 0, and you're left with, well, of course, 2, 6. And then here, 3 gets incremented by 1, so you get 4 and 12. So this is what we're expecting as our output. So let's now run that. So we're going to say print matrix. Well, we need to make a bias. So auto bias is equal to create bias. So print matrix mapmul plus bias A, B, and little b. And I'm just going to make some room between the first and the second matrix. Let's compile this and run. And you can see that we get exactly what we computed, 2, 4, 6, and 12. Okay, so that's how you do matrix multiplication plus bias. Hope to see you in the next video.